Hi everyone, we're Team 6. My name is Zhixuan and I'm joined by Mahir and Mahika. And today we are going to walk you through how we made diffusion transformers train faster without sacrificing image quality. The core challenge is the diffusion transformers are expensive to train for two reasons. First, attention is quadratic. More patch tokens quickly means much higher compute. Second, standard flow matching uses random noise data pairs, which often leads to unnecessarily curved trajectories. Most prior work handles these bottlenecks separately. We ask a different question. Can we make training cheaper by improving both the compute and the trajectory at once? Our task is a re-implementation and extension study. We train on ImageNet 100, that's a 100 classes of everyday objects like dogs, birds, and cars at 128 by 128 resolution. We generate 5K images for FID evaluation. Nexus. We encode each image into a compact latent space, match noise to data using the OT pairing, and interpolate between them to form the training steps. These samples are fed into a DITXL models with adaptive masking and cast conditioning. We train with a L2 loss, and in first time, masking is turned off, and we generate samples by solving the flow with owner steps.
So now I'm going to talk about smart dispatching for noise data. If you see on the left, we have a random pairing, whereas on the right, we had the OT pairing. As you can see, short distance as more straighter trajectories, and we use Hungarian algorithm for that. For the next slide, we are going to talk about the time adaptive masking. We started like an artist who starts with a rough sketch and only filling final details at the end. We started with zero tokens, and now as we ended with 75% tokens at the end, as you see, as the tokens are cleaner, we have zero quality lost, and the masking turns off. Next, we are going to talk about the 2 into 2 factorial ablations that we used. We have four major boxes: the baseline, masking, OT only, or both of them. As close it is to zero, the better it is as the interactions speed up, and we use 5,000 images for it. Now we are going to talk about the training loss curve that we had over all the experiments. We started with 1.9, where we finally had a drop and we went down to 1.03 after the first 10 epochs, and our minimum loss was 0.64 epochs over the 290K steps that we had completed over 7.8 iterations per second at a training speed.
So now talking about the scale suite, we also validated across different scales, saying supposingly DIT XL, DIT large, DIT small, and even a unit baseline all trained stably. The caveat was that DIT large hit its wall time limit early, so comparing step counts directly is like judging a marathon runner who only ran 10 miles. So now on the starting point on the left, you can see the Gaussian noise. This is a black canvas, pure chaos, where the model has no idea what it's looking at. And then comes the aha moment. Notice that even before training is finished, the class structure is emerging. You can clearly distinguish the textures of a bird, the feathers, the scales of a lizard, and even the greens of a natural habitat. The bottom line is, while they aren't pixel perfect yet, these samples prove that our OT pairing is adaptive and masking is working. Now, finally, the limitations and future work. A few honest limitations that we faced was that each config was trained with a single seed, so we do not have variance bounds yet. We only tested on ImageNet 100 at 128 resolution. And some scale sweep configs hit SLURM timeouts at different step counts. Now, the next steps that we would like to do is have multi-seeded rounds, higher resolutions, and exploring alternative masking schedules beyond our cosine squared choice. And finally, the conclusion. To wrap up, we built a fully working pipeline that built OT pairing and combines it with adaptive masking in one DIT training loop. Stable training, promising loss values across all scales are tested. The key question is whether these techniques are truly additive, and the 2 by 2 factorial will answer that. Thank you. If you have any questions, please find us out on Piazza. The next slide is just references that we have used to help us throughout this journey. Thank you.